Welcome, as I say, welcome to the Meetup. My name is Mark. I'm a developer advocate at StarTree. And what we're going to be doing in this Meetup is talking about the real-time analytics stack. And so I guess the intention of what we'd like you to take away from this session is just sort of a broad understanding of this sort of tooling that people use to kind of build applications in this area, and maybe not like expert knowledge in any one of the areas, but just like, okay, I can kind of see, like, I understand what stuff is available and how it fits together. So that's the goal of the session. So to start with, we've got to work out, okay, so we're talking about a real-time analytics stack. So it's a stack of stuff for real-time analytics. So what is real-time analytics? So this is the Gartner definition, which is sometimes a useful place to start. So they say it's the discipline that applies logic and maths to data to provide insights for making decisions quickly. And I guess the bit in bold is probably the most interesting bit from our perspective. So we've got data and we want to try and understand it so that we can do something with it. We can take an action, or i.e. make some sort of decision. So how do we apply that back to the world of data? So that's quite like an abstract definition. So in the world of data, hopefully you're all reasonably familiar with events. So events they're generally like stuff that happened in the past, right? Like it's facts about something happened in the past. I did a search. I bought something from the shop. I RSVP'd to a meetup. I joined the meetup. I searched for pizza. So it's something that happened, and there'll nearly always be some sort of time associated with it, and then there'll be some facts that are properties of that thing. And the events on their own are cool, but really we want to make some insight in them. Like, what can we learn from that event, or even what can we learn from like aggregating some of those events together? And then once we've kind of like started like trying to get some insight on them, we ideally want to take that insight and be able to do something with it. So if we know someone's searching for something, the action might be, okay, let's get like a voucher for a pizza or a voucher for a burger place so that they can go and buy something. If the action was RSVPing for a meetup, maybe we're going to figure out, like, we're going to suggest, I don't know, perhaps we're going to suggest like some other ones like that they might be interested in as well, like, or some other things on the same topic. If it's, I just added something to my cart, on e-commerce, they often will say, hey, people who added this one also added this thing. So it's always like, what can we put in the flow? Like, imagine like it's in the click stream. So you're like, what can we do to like either encourage people to buy things that they might be interested in, or engage with our website more if it's more than that. And so it's all like, but can we encourage people to do something, or can we do something ourselves? And so in this world, data generally loses value over time. And so the most valuable point for the data is when it just happened, or maybe just a little bit after that, like say a few hours after that. And then as time goes on and sort of you get to the data that happened yesterday or last week, it becomes less a case of being interesting for real-time analytics. And then you sort of go more towards, okay, that data is probably going to end up in a data lake somewhere, or maybe in a lake house if you're using a more modern approach. And we're going to go and analyze it. Perhaps we're going to analyze it with Snowflake or Redshift, or whichever tool you're using to analyze historical data, because I guess at that point it becomes more historical. So for the context of our talk, we're like data that happened now or just in the recent past. And so it can be interesting to lots of people, right? So to begin with, like, analyzing this data was often the domain of analysts inside a company. So we'd be building like, okay, here's a nice dashboard that we can use inside our company for just like tens of people. And maybe then we can move that data up to the management. So we can go, hey, we've got all this data, we're collecting the data. Here's like real-time reports on what's happening. Oh, by the way, we've got a big problem happening here. Can we do something about it? So imagine we were like running like a e-commerce shop. Maybe we see like, oh, there's a shortage of something. Okay, let's make sure we're not trying to sell it. Or can we actually make an order to our supplier to get a copy of it, like, or an extra versions of it? But more interesting is that this data is also actually interesting to users. So can we build products, like data products, real-time data products for our users, often based on data that was originated from them, in some way that's giving them some benefit? So i.e., is it letting them gain some insight into their use of something that then makes it a better experience? Is it that we are helping them to buy things that are more suitable for their lifestyle? Like something where we can sort of loop that data back to the user. And once you start like feeding these analytics to the users, obviously you have way more people who are interested, and you sometimes end up in a bit of a flywheel where the users, like you create a data product for a user, the user then uses it, that creates some more data, and then you maybe come up with another product. And so you can actually sort of get into a bit of a cycle of creating like better and better products as a result of feeding real-time data to users. So let's just run through some examples of applications where people have done this already. So LinkedIn is a good one. And so StarTree, the company, many of the people who work there used to work on Pinot at LinkedIn. And one of their core products that they use this for is the Who Viewed Your Profile. So this is a page where you will get to see like, hey, here, these people looked at it, and you kind of get a real-time view of how many people are looking, what's the change since last week. So that's kind of interesting, right? There's a little bit of historical versus real-time, or like just this like recent past. And if I went and viewed your page right now, you would see it like at the top of the page. Hey, or if you're on the premium, you definitely see that I looked at your page. I guess if you were on just the normal LinkedIn like me, it might say a person in the software industry looked at it, right? So and so this type of thing is useful, and it's engaged with a lot because people are like, oh, who's looking at me? Is there like an opportunity for a collaboration? Is there an opportunity for a job for me? Like this is really actually improving people's experience with the LinkedIn platform. And you can see on the right-hand side of this slide, we're sort of looking at the usage of this. So they have a lot of users, right? Hundreds of millions of users, and they're really engaged with this feature. So we're operating on the tens of thousands of queries per second. Another one is the newsfeed, and this is the LinkedIn newsfeed, but you can imagine like any newsfeed for a social media site is going to be similar, and the goal is similar. It's like, can I show you a thing that is interesting to you? So I want you to like it, I want you to comment on it. In LinkedIn's case, I want you to share it, like repost it. Like I want you to take some action that says, yes, I like this content. And so they use it for this as well. So like, how do we make sure that we're building this newsfeed in a way that the stuff that we're showing you is fresh, like is new stuff? I'm not showing you the same thing again. Like how do we do that? Like that's the real time part of it. So I don't want to come back like in 10 minutes time and you're like, oh, here's the same thing again, right? So that's the real time aspect. I want to take into account, what have you just viewed? Which sort of things do you interact with? And then I get the next time you come, you maybe see a slightly different feed. The talent pool report is another good one. I guess this has less users than the other two because this one is more like a premium feature. So this is kind of a recruitment tool, and here it's like a narrower set of users, but still like keeping like real-time tracking of what is actually happening, like what jobs are available, what people are available, like can we match them together? Another one is Uber Eats. So this is a dashboard that restaurant managers get. So a restaurant manager would be like somebody running their restaurant on Uber Eats, and they get a dashboard. So in this case, it's the pizza place, and they can kind of see like in real time what's happening. And I guess this would be mostly useful around mealtime, right? Like around lunchtime or around dinner time to see what's happening. Like, have we missed an order? Can we go and fix that before the customer decides, okay, I'm never using pizza place on Uber Eats again. I'm going to go to like another pizza place, or I'm not going to get a pizza, I'm going to get a burger. Have we made a mistake with an order? Have we got some inaccurate orders? Can we fix it? Are we getting bad feedback or good feedback on an item? If we're getting good feedback, maybe we want to push it to the existing customers. Like all of these are like stuff that's happening like as in that particular evening. In the real-time analytics flow, if you like. And so the way I like to think of this one is it's kind of like trying to provide the service that you would get from a really good server in a restaurant, where they can see everything that's happening. They can see the customers who might need some attention, but obviously we can't see them because it's all digital. But it's like, can we achieve the same type of service that a really good restaurant achieves? And again, like here, there's we do lots of queries, but maybe not as many as what we had on the user-facing application for LinkedIn. So those are some examples. So hopefully you kind of got like a rough idea, like what type of things are we? Can you build with these real-time analytics techniques. Now I want to give you a map. So what tools do we need? And the intention of this map is so that when you see, there are often new tools, like you'll see new tools all the time. And I want you to be able to go, okay, I know what that one is. That fits into this category. Oh, okay, that's an interesting tool, but it's very, very similar to this other one. So I want to kind of give you like a bit of a map to understand what's going on. And broadly, like at a very, very, I guess, coarse level, there are 5 types of things that we have. So we've got event producers that put data into a streaming data platform. There's then potentially a stream processor operating on that data. The data then goes from a streaming platform and it needs to be able to get to the user. It generally goes to a serving layer of some sort, and then there'll be a front end that then is interacted with by our users, whoever they may be. So there are you'll see other diagrams that have more stuff, but at a coarse grain level, these are the 5 things that are always going to be there. So let's have a look at them in detail. So let's start with event producers. So this is the very beginning. And what we need to do is we've got a streaming platform, whichever one it might be, or pick your favorite streaming data platform, but we've got to get the data in. Now, where does the data come from? So there are a few different places. So one of them is maybe it comes from our existing operational databases. It could be like an OLTP database. So maybe it's MySQL, maybe it's Postgres, maybe it's Oracle. I suppose if it was NoSQL, it could be Mongo. And we've got some data that's coming in there, and it's probably being operated on by a transactional system somewhere. Perhaps it's on a website, and the data's coming in here. And we're like, I can't really do my analytics on there because it's ending up like locking like all the rows and messing up with my transactional workload. So I kind of need to get that data somewhere else. And so one technique you may choose to do is called change data capture. And so we can kind of capture like a stream of the changes that are happening on that operational database, and we'll put it into the event streaming platform or the streaming data platform, and then we can do something with it later on. That's one source of data. Another one is maybe we've got an event tracker. So we could be using something like Segment or Snowplow, maybe even Google Analytics, and we're capturing like the events that are happening. So maybe someone clicked on something, maybe someone visited a page, maybe someone opened the mobile app. Like all of these are events that might be interesting and will tell us something that we can then take some action on. So we might be streaming those in. And then if we want even more control over the events that we're creating, we might go down to the SDK level. And here you can pretty much create whatever you want, right? Like you have complete control. You can decide what the event's going to look like, what format it's going to be. Is it going to be JSON? Is it going to be Avro? Is it going to be protobuf? What is it going to be? What's it going to be in the message? You can pretty much control it completely. And you can likely do it from whichever programming language you want as well. Generally, all the streaming data platforms will support the major languages that people use, with Java, Python, Go, Node, whichever one it is that you're using. So that's how we get the data in. Now the data comes into the middle, and this is kind of the core of the whole thing, is the streaming data platform. So what is a streaming data platform? So generally what they do is they're ingesting data from those sources in a scalable way, and they're storing them durably. So potentially, like conceptually, you could think of it as like an infinite stream of stuff, although obviously it will be truncated at some point. And so a common way that those messages are stored is in topics, and a topic would be analogous to a table, I suppose, where it's like some sort of data, and it will be like a stream, like imagine like a list of some stuff. So it could be a topic capturing those orders. It could be a topic capturing products and the changes in price. Like maybe we're capturing a feed of the products and how they're changing over time. And as I say, there'll be like a log. So there'll be some sort of distributed log. It's often will be partitioned, and you'll have multiple copies of that log, one for each partition. And we are appending to the end of the log. And as I say, like those logs, that log will be durable and scalable. So ideally we'll be replicating the log somewhere, and we'll be able to, because of partitioning the log, we can handle like multiple people creating that data, and then actually also multiple people consuming the data as well. And so here's an example. What would a log look like? This is from an imaginary Kafka partition. And so we've got all our records, the left-hand side of the older ones and the right-hand side of the newer ones. This is Kafka, but pick your streaming data platform of choice. It will be very, very similar. There are lots of choices. So you could kind of take your pick. So Kafka is the most common one, but there are other ones, and they all have some features that are maybe unique to them, and then some things that make them better. So that they claim that make them better than the competition. But I guess you got to look at which one fits best into your architecture, which one are you most comfortable with. So be it Pulsar, Red Panda, Kafka. If you're working in Google, maybe you're going to use the Google Cloud. If you're working perhaps you're going to use if you're working in AWS, perhaps you're going to use Kinesis. And there are lots of other ones as well. So you got but again, broadly they're doing the same thing. So they've got stream of data, and they allow lots of people to put data in, and then lots of people to get data out. And then there are obviously way more features on top of that. But at a high level, that's what we're doing. So then that moves us on to the next piece of our map, which is a stream processor. Now, what a stream processor does is it operates on the data in the event streaming platform. So generally, and sometimes you'll see this talked about as a source, and there are some streaming platforms that can take in more than just an event streaming platform as their source, but for the context of our talk, we're just going to assume that the source is an event streaming platform. So they'll take that data in, and then they'll do something with it. So it could be they're actually taking in data from two topics and joining it together. It could be that they are creating a materialized view from the data that's come in from one of those change data capture tools. It could be they're doing some sort of streaming ETL. So maybe they're filtering some stuff. Maybe they're joining it with some. I guess we talked about joining. Maybe they're doing some cleaning up of the data. Maybe they're doing some temporal operations. Maybe doing some sort of aggregates in there. And then so the source comes in, we do some stuff with it, the source or multiple sources, and then we send it out. And sometimes you'll see where it goes is called a sink. And so a sink could be, in our case, we're going to just look at the sink as if it was a streaming platform, but it is possible. Some of these stream processors will let you actually put the data straight out into a serving layer or into somewhere else and skip kind of going back to the streaming data platform. From the stream processor, the data sometimes goes in other places as well. So it could be used for streaming analytics. So perhaps we're, as I say, doing some materializing of streams, or maybe we're doing some window operations. Or perhaps we're just using it straight in a microservice. So maybe we're operating on top of that stream in a microservice. So we're doing some sort of event-by-event processing. And then the particular bit of stream processing that we are interested in is streaming ETL. So we're kind of getting that data, and then it's going back into the stream again, which then leads us to looking at the technology choices. And there are loads of these, and there are always more coming along. So probably the most well-known one is probably, I'd say it's probably Flink. Newcomers in the Python space are Quix and ByteWax. Those are kind of interesting. An older one, which was very interesting a couple of years ago, is called Faust, but it seems maybe like it's not really being maintained at the moment. So I think maybe the other two are better choices if you like to do Python. Kafka Streams, if you're happy with Java. Materialize is an interesting one. That's sort of interesting, almost sitting on the intersection of stream processor and database. It's kind of fascinating. And then you got some custom ones like memgraph, where they're doing graph operations on the stream. But yeah, all of them, again, at a high level, they're taking some data from a stream and doing something with it. That then leads us over to the serving layer. So the serving layer takes data from the event streaming platform, and generally it needs to be able to get the data in quickly, right? So the data's come into the streaming platform, so we need to be able to ingest it very quickly. We should then be able to serve queries with very low latency as well. So ideally, we want to be able to achieve what we call OLTP type latencies on OLAP queries, right? So we're querying everything, but we want the results to be quick. And so that kind of also, the next part of that is that we want to be able to have lots of users do this at the same time. So i.e., we need to be able to support a high throughput of up to hundreds of thousands, maybe even millions of queries per second. And that can be done so the architecture will need to be able to scale out to multiple machines so that we can have our queries operating on those different machines. And then often what we'll want to do is we want to run some sort of complex OLAP queries on there. We need to do some joins, especially we need to do some aggregations, and perhaps we want to do some filtering. Maybe the filtering is going to happen before we put the data in, but perhaps we also want to do some filtering once the data is in there as well. Technology choices here kind of split out into sort of two types. So on the left, we've got kind of key value stores, NoSQL databases like Mongo or Elasticsearch or Redis. These are really good if what you want to do is I basically need to look up a key and like show me the latest value or sum some values up based on a particular key. So if I want to do that sort of lookup, this is a good choice. If I want to do something more complicated, maybe I want to do like clever indexing across different columns, or maybe I need to have a lot more flexibility over the types of queries that I run, and I'm not entirely sure what I want to do with it. Probably you want to drift over to using one of the real-time OLAP databases. And the one that we're going to be using in this meetup is called Pinot, but as you can see, there are other ones as well. And they are all operating in a similar way in that the data is coming in from the streaming data platform, and then we're going to serve it to someone. It could be to an analyst user, or it could be to an application. That then leads us to the front end. So the front end is like, well, how are we going to get the data to our users, be the users, the analysts, the management, or the end users? So it could be we build something ourselves, right? We could just crank out the React skills or the Vue.js skills, and we're just going to build our own UI. Or perhaps we're going to use the low-code frameworks. Perhaps we don't want to do a bunch of front-end coding, so we're going to kind of automate a little bit of that. We're going to use Streamlit, or we're going to use Dash. Or perhaps we're going to go even further. And these tools, I guess these ones are more if it's internal users. Perhaps we're going to use a data visualization tool like Superset or Metabase or Redash, and they kind of give us much less code to write, and it's more like tell it what the schema of the database looks like, and then we can sort of drag and drop different fields to create charts and visualizations that are interesting, often for a dashboard, I guess would be what you're building there. Okay, so let's have a demo of an example that glues these things together. So all about that dough is an imaginary pizza shop that my ex-colleague Judith and I came up with. And so we were imagining a pizza delivery service, and we took a bunch of pizzas from the Domino's India menu because it just sounded cool. Like they have some cool pizzas on there, and also the menu was available. And so we wanted to build something that shows what would a real-time analytics look like for a pizza shop. There is an article explaining this pizza shop demo. Equally, you can go to this link, or if you have your phone, take a picture of this QR code, and it should hopefully show you the link, and then you can get to it. So if you want to play along, that's probably a good way to do it. What we're going to do is I'm just going to walk you through some pieces of it for the remainder of the session. So this imaginary pizza shop has an existing architecture, and it kind of looks like this. It's a little bit kind of disjointed at the moment, but imagine we've got some users down the bottom left-hand corner. They're submitting some orders. The orders are coming into an orders service simulator, which is then putting them up into the orders stream. And then maybe we've got some things operating on that stream, but not at the moment real-time analytics. And then over on the operational side, we've got our users and our products stored in MySQL. And so what we want to do is get from that architecture to this one, so add in those pieces that are in the red. So we want to take the orders, put them into Pinot, so that we can actually build an initial dashboard. So that's this sort of bit here. As we can build the dashboard using Streamlit to have a look what's happening with our orders. And then we want to also be able to join the products with the orders so that we can kind of get an enriched, we'll show what the orders look like in a minute, but inside an order, we have the items that comprise the order. We're going to explode those out and then join them with the products so that we get what we're going to call the enriched orders item stream. We'll put that in Pinot as well, and then we'll create a dashboard on top of that. So that's the plan. So let's have a look. I'm going to start by showing you what the MySQL looks like. So that's kind of an interesting place to start. So I've got this MySQL password is the password, and we'll say, hey, I want to use pizza shop. Show tables. Oops, can't type. There we go. So you see, we've got products, we've got users. We could then say, hey, select star from products. Like that. So I forgot what it is. There's a clever way that you can get it. Oh, never mind. I'll just show it like this. You can see we've got, hang on, let's put a limit on it. So these are some of the products. You can see we've got a category, we've got a name, so the Moroccan spice pasta pizza tells you a description of the pizza itself. We've got the category of the pizza. We've got the price, so this is a price in rupees. Jeremy loves Streamlit. I love Streamlit as well. Streamlit is very cool. I'm going to show you something we built with it. We've got an image of the pizza, and then we've got the date when it was created in the last touch. We've got some different things as well. So we've got tikka masala pasta, we've got Lipton iced tea, we've got chicken pepperoni, we've got some garlic bread, we've got loads of different things, and then we can have a look at the users as well. And so you can see we've got the users, and we've got email, country. There is a shortcut for MySQL where you can, I can't remember what it is though, MySQL. Where you can get it to like kind of not like, so if the table is sort of too wide, it's a shortcut. I can't remember what it is though. It's like a syntax. Table too wide. See if I can remember what it is. Anyone knows, let me know in the comments because I can't remember. There's like a syntax you can stick on the end. I thought it was like the /r, but it wasn't. Or like /. Oh no, I don't think. Oh, now I've broken it. We'll give up on that for the moment. Okay, so that's MySQL. So we've got our users and we've got our products. So now I want to have a look at, so remember they've got Kafka running as well. So we can have a look at the events in there. So we can call this kcat command. So kcat is a tool for, in case you've not seen it before, oops. So I'll just show you kcat. It stands for Kafka cat. It's kind of like the cat command that you got on Linux, and it allows you to basically cat, like show me what's in the stream. And so in this case, we're saying I want to call kcat in consumer mode. I've got a broker, which is running on localhost 29092. I've got a topic, orders, show me 10 things. Or you could even say, don't show me 10 things. And that, I mean, that's what you get. -u says, don't buffer. Let's restrict it to 1, and we'll pipe it into the JQ. JQ is a command line JSON processor. This is what we get. You see, this is what a message looks like. So we've got an ID. It has the created at time. We've got a user ID, we've got a status, price, and then a bunch of sort of items sitting in here as well. Now these are coming from an event simulator. Now, let me see if I can, maybe I'll just quickly show you the simulator. So orders, service. So this is the simulator. So what we're doing is we've got a bunch of products. We are selecting a random pairings of those products down here. So you see we say, hey, randomly choose me some of those products, randomly choose a user, randomly choose a quantity, and then do the purchase. And we're kind of then computing a couple of aggregates here as well. So like the price and yeah, just the price. And then we send it to the orders topic here. So this is using a Kafka producer, and every 100 messages we flush it. So that's it. That's what the event generator is doing. So we are in that third category, right? So we are just putting the data there ourselves. Like we're not using any change data capture. We're not using a change data capture tool, and we're not using an event tracker. We are creating it ourselves. Okay, so we then want to get that data. So the data is in the stream, right? So we can kind of see like. We can pipe it. So this is all the data, it's all flying through. We could say, hey, I want to start from the end. And you can see these are new orders. So this is like, yeah, right now. So orders are coming through. This pizza shop is extremely popular. It's not restricted to just meal times. It's all the time getting orders. What we want to do now, though, is have a look at how do we get this data into Pinot? So Pinot, when you're creating its abstraction is a table. So you have a table, it has columns. Generally, a table will have lots of columns. It will be quite wide tables that people are operating on. Now, to create a table, the first thing you need to do is specify its schema. And its schema is very similar to like a data definition language if you were using SQL, where you're going to specify what are the columns that my table has and what are the types on those columns. It uses the language that you'll see in data warehouses. So you can see we've got a schema name, it's orders. We then specify some dimension fields, and dimension fields are generally used for filtering or grouping by. And so in this case, we've got ID, we've got user ID, we've got product, we've got status. And I should say that each of these map to the source data. So in this case, the Kafka stream. If it has any of these fields, they will map directly when you try to ingest the data. So that's dimensions. We've then got metrics fields. So metric fields are the ones that we are summing on, like we are doing the aggregations on these. And they are quantity and total in this case. And then finally, we've got date time. So for real-time tables, i.e. ones where you're getting the data from a stream, your source is a stream, then you should have a timestamp. It is possible in Pinot to do what we call a hybrid table, where you kind of join together. I've got some historical data, maybe it's sitting in S3. I'm going to load that in. That would go into an offline table. I've then got a real-time table with the same name, and I could do a query of the two together. The use case for doing that would be, hey, imagine I've got like in our pizza shop, I've got all the data that happened like for the last 3 months. I want to load that in so I can compare what's happening now with what happened then to see, are we doing better? Are we doing worse? Is there a problem somewhere that we were not experiencing before? So that again, it's helping me to make decisions in the present by looking perhaps at data that happened in the past. So that's the schema, and then we can do the same for the table. So you have these two things, two JSON files that you need to create. This is the table config. The name needs to be the same as the schema. So in this case, it's orders. Notice that we specify the table type real time. If it was one of those batch historical data tables, we'll call it offline. We specify where the time column is, the data type in there, and then also the name of our schema. And if we scroll down, because we had the word real time up here, it's going to expect to see this stream configs entry down here. If you don't have it, it will throw an exception and say, hey, you're missing your stream config. I don't know where to ingest the data from. You then specify the type. So in this case, it's Kafka. We indicate the consumer type. So the consumer type is how am I going to ingest the data from Kafka? There's two choices. It's high level or low level. High level means, hey, take all of Kafka's partitions and treat them as if it's just one partition. So obviously that restricts the ability, the throughput that we can, the amount that we can consume that data from Kafka. If you put low level, it's going to be like, okay, each partition, I'm going to spin up a consumer. I'm going to ingest those in parallel. We then specify the name of the topic, and then we've got a couple of classes indicating how am I going to decode the data that's coming in, like what factory am I going to use and what class is going to decode it. And then we've got our broker list here as well. And then if we scroll down, we've got one interesting feature of Pinot is that you can define what we call transformation functions. And so these are for doing like just little adjustments to the data as it's coming in from your streaming data platform. So in this case, the timestamp for our messages or for our events wasn't quite in the correct format that could be consumed by Pinot. And so we're just going to tweak it a little bit using this from datetime function. This is not a replacement for what we said we do in a stream processor, but a stream processor would be for doing bigger things, right? If it's just like, hey, I just need to slightly change one message, probably you can just do it in here as long as there is an available function. Okay, so if we were running this, we would then call our add table command. We pass in the schema file and the table file, but I've actually already cheated and done that for us. So we're going to come over here, and you can see this is the orders table. Notice that the orders table has a schema. So you can see the schema just below. I'll make it a bit smaller. And if we click on the orders, you can kind of see the orders coming in. So if we just scroll down a little bit, you can see we've got the orders, it's got the items. If we come across a long way, we've got the price, the number of products ordered, the total quantity, the timestamp, and the user. So that's the table. You can also view the underlying table config. So we can come in here. We can go, hey, I want to edit table and have a look at it. And so this one's actually got a couple of extra fields than what I showed you. So you can also add in what we call derived columns. So these are like columns that are based on the data that's in the other columns. So in this case, we are adding total quantity and products ordered. And so what those do is, or one of them is going on the items column. So items is adjacent, like it's the JSON from inside our event. And it's kind of going in there and saying, hey, I want to sum everything that has a quantity, i.e. go and get me all the quantities of the items and add them up. And then the products ordered gets populated based on this JSON. It's basically a JSON path expression that says, hey, I want to know how many products were in that list. So was it 5, was it 3, whatever it was. And you can see everything else is kind of the same, right? Like low level, Kafka, orders. Now data, when it's coming into Pinot, then gets stored as segments. So you can see here we've got a segment. A segment in this case, it contains at the moment, this segment contains all the rows and all the columns, but in general, it will be a subset of the columns. And it looks like this one is going to be what we call committed once we get to, what was it, 5 million records. Now we could obviously query that orders table. So you could say, hey, I want to know find me the orders that happened in the last 2 minutes. So we've got nearly 2,000 orders. We could say 5 minutes. That's 4,000. We could say, I don't know, what users ordering them. By user ID. Yeah, so you can see we've got some users doing loads of orders. We've only got 1,000 users, so it's not entirely surprising that we've got some who do multiple orders. Now this is not too bad, right? This is a decent start, right? This is a potentially reasonable API for an analyst or someone who's really comfortable with SQL to be using. But generally, if we want to give this to an end user, we need some sort of interactive API. And so I've built one on top of this data set using a tool called Streamlit. So now I should... Jeremy loves Streamlit. So Streamlit is, if you've not seen it before, let's have a quick look. It's classifies itself as a faster way to build and share data out. So it lets you write stuff in Python, and then it builds an interactive front end on top of that. And I'll show you the code in a second. But this is the type of thing that you can build with it. So you can see we've got a dashboard here. It's auto refreshing every 5 seconds. We could make it more frequent than that. So now it's updating every 2 seconds. These are the orders coming in on the left-hand side. And then on the right-hand side, we've got the revenue per second. And we can kind of tweak that, right? So it's showing this is what happened in the last 1 minute. We could also look at what's happened in the last 30 minutes. I think this is since the start of the talk, more or less. So this is what's been happening. Or we could do 5 minutes as well. And so you can see we've got there's more variation if you look at recent times. We also, I think, this stuff is actually extra. We'll talk about that in a minute. And then this is the latest orders. And so if let's just go back to our command line and have a look at how we built that app. So this is what it looks like. So we're getting in some config for Pinot. So we're querying against the broker and with a port. And then what we do is we create a connection to Pinot. We create a cursor. And then we can execute a query. So this one here is saying, hey, have there been any orders in the last 2 minutes? So that I can, because otherwise everything else doesn't work. So it's going to throw an error if not. And then when we come down a little bit, this is what is populating the little bit at the top. So we're doing what we call an aggregation, kind of aggregation filter, aggregation with a filter. So saying count everything where the time is greater than 1 minute ago, and then also count everything where the time is less than 1 minute ago and greater than 2 minutes ago. And we're also then filtering down here to say, hey, I only want the stuff that happened in the last 2 minutes. So I guess probably we could get away with not having this and it would be the same. But we could try, right? So you can try this query yourself and see what it does. What have we got? We've got a typo somewhere. Here. Oh, maybe the N. Yeah. I think, what's it? 94993. I think we don't need this. Yeah. This is kind of implied by. And these numbers will change as you refresh. So that's like one of the queries. And then what we do with it after that is then we build the data frame, and then we use something called Streamlit metrics to render it. So Streamlit has this concept of a thing called a metric, which is one of those big numbers with a potential delta underneath it. And we're then splitting the screen into three, other into two, maybe into three. And we're showing the orders. Oh, sorry, yeah, three metrics. So three metrics side by side. We've got the number of orders, the revenue, and then finally the average order value. So that's here, right? So the average, so the orders is 4,700, the revenue is 20 million, and then the average order value is 4,400. Remember, that's in rupees. And then all we're doing is like quite a simple query, right? So saying, hey, get me the value from the, I think it's from the data frame, right? Yeah, so we're grabbing the value from the data frame here, and then we're grabbing one value from the data frame, subtracting it from the other one over here. And then for the chart, we're running this query here. What this query does is it basically does a aggregation by minute in P9. So this is what you get. You get like all these times and then the count in that minute. So 42, 40, or 41, 42, 43. And you see how many orders, and say how many orders have happened in that minute and how much revenue. And you'll notice that for the latest minute, it's always going to be slightly less, right? Like, so 16:43 is like, we're only 20 seconds in, so we've still got some time to go. And then we are feeding that, where do we do that? We feed that into a Plotly chart. This is kind of more complicated than it probably needs to be, because I wanted to make sure that the last bit of the line was dotted, this bit. If you don't care about that, you can kind of scrap this and literally just render it. Like, you can get rid of all this, get rid of all this, get rid of all this, and just go, hey, render this line. Oops. Okay, so that's the Streamlit. Right, now let me show you how we would go about joining the products together. So I'll do this as by the way, if you have any questions, feel free to ask them. This is the products. We have manually written these products into this stream, but if you were building a real system, you probably want to use a tool like I mentioned at the beginning to get the data across, like Debezium, for example. We can then, this is how we're then joining the products with the orders. And we do that using, we're actually doing that using Java. So we've got this Java code here, a bit big. But what it does, we've got an orders topic, a products topic, and the enriched order items. We then build what we call a K stream. So this is Kafka streams for orders, and what we call a K table for products. Kafka streams talks about what it calls the duality of tables and streams, where you could consider that a table is like the latest value for a particular key. So if it's the product, for example, it's the latest price and the latest description. Whereas a stream is like the change log of what could potentially be a record in a table. So if it was a stream of products, it would be like, hey, here's the history of the product. Here's maybe the ID would always be constant, but hey, here's the names of the product. Here's the times, the prices that we've charged for it. Here's the ways the description has changed, right? So and then if we wanted to go back again to the table, we go, okay, we're just going to get the latest one. What we're then doing is we are exploding out using flat map the orders. So pull out the order items. So order items are like in an array, and we're going to flatten them out. And then we want to join them with the products to get the enriched items. And that's it. That's what this code does. You could do it in another tool. You could do it in Flink. You could do it in whichever tool you like, whichever stream processor is to your fancy. And what we end up with is this. So we got the order ID and the created at date, and then we got the product and the order item embedded in there. Probably we don't really need the order item. I just put it in so I could check that the two sides were joining up. And then we're going to create a P-node table for that as well. So if we come over here, see we've got the orders items enriched. It's pretty similar. So if we look in here, you can see this is the table. It's kind of the same, right? The name is a bit different. the topic is a bit different. Everything else, more or less the same. Again, we've got a segment. It's trying to get to 500,000 items. At the moment, it's done. 280,000. And you can query this as well. Like it's a little bit different. So you can see we've got an order ID, we've got the product category, we've got the product ID, we've got an image, product name, product price, and timestamp. Now on this app, these bits here in the middle are actually coming from this table. So you can actually query different tables in the same app if you want to. So for the popular items and the popular categories, we are querying the enriched order items. And then for the summary stuff at the top, we're querying orders. We could then, if we wanted to, we could extend this app further. I don't remember if there's anything else to show you. I think I've showed you everything. We've actually got like an even more extended version if you want to play with it. So cool. I'll paste it into the chat. So this one kind of goes even further than this and introduces some other things as well. So as well as just, oops, sorry, I was in the wrong page. So on this one, we've got, we're also showing how to do stuff with Flink. So we've got the orders, we've got the products, and then we join them together in Flink instead of in Kafka Streams. If you want to have a look at how to do it in Flink, you can take a look over here. And instead of that Java code, we effectively can do the same in SQL. That is more or less what I wanted to show you. I just quickly wrap up with some slides. So thanks for coming to the talk. If you want to learn more how to do stuff, obviously I showed you a link before. Take a look at the Dev StarTree AI. Again, if you have a phone or you want to just grab that QR code, it will take you to the page if you don't want to type it in. And please join us on the Slack as well. We have lots of people there. If you're doing Pinot stuff or doing anything in the ecosystem, we can probably help you if you're stuck. So please come there. And then I've got a YouTube channel, and we've got a bunch of videos on the StarTree one as well. And there's a book on this sort of topic, this pizza shop demo, but built out even more. If you look on Safari on O'Reilly, it's called Building Real-Time Analytics Systems. So if you're interested in that, then please have a look at the book. Otherwise, if you have any questions, please let me know on the chat. Cool. No problem. Red says thanks. Yeah, no problem. I'm gonna give you a couple more minutes if you have any other questions. Otherwise, I guess we'll call it a day. If you want, as I say, if you think of a question later, please come and join us on the Slack. I pretty much have that open for the whole day, looking to see if there's anything that I can help with. But otherwise, thank you very much for spending your time, and hopefully it was useful. And give it a try. And if you want to copy any of the code, go for it. Just copy the code, adjust it for whatever your use case is, and that'll be awesome. So thanks for coming, and I guess we'll see you in the next meetup. Bye, everybody.